So human in the loop is a more like interactive machine learning concept. If you think about machine learning model or AI model, we can think fully autonomous system. So you build a model and then you let your model or your system run by itself to do something. But human in the loop is more like human and machine can interact with each other to solve problem together.
Welcome to the Conversations on Applied AI podcast, where Justin Grammans and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry and connect with us to learn more about our organization at appliedai.mn. Enjoy.
Welcome to the Conversations on Applied AI podcast. In this episode, we speak with Bongjun Kim. Bongjun is an AI researcher at 3M. He completed his PhD in computer science at Northwestern University, and his research interests include machine learning, audio signal processing, such as sound event recognition, interactive intelligence systems, multimedia information retrieval, and human-in-the-loop interfaces. He also enjoys working on a musical interface and interactive media art. And being a musician and a bit of an audio geek myself, Bongjun, I'm very excited to have you here on the episode today. So welcome.
Thank you. Thank you for having me today.
Awesome. Great. Well, so I gave a short background, about you and where you're at today. I guess, how did you get to 3M? How did you, what's sort of been your career path?
Yeah, so actually my career path is all over the place, really complicated. So currently I'm a data scientist at 3M. So I completed my PhD in computer science, as you said, at Northwestern University. I actually graduated last June, then joined 3M a couple of months ago. So during my PhD, I have been working on a lot of interdisciplinary projects, mostly focusing on machine learning and interactive intelligence system for audio, specifically for audio applications. Before doing my PhD, I also have worked on some musical interface and media art during my master program in Korea.
Gotcha, for sure. So it sounds like you've been really interested in audio sort of from a young age, maybe?
Yeah, actually, I really love music, and this my biggest hobby is to make music. And so I wanted to somehow connect my engineering knowledge skill to some music audio, applications. So actually, I didn't go to PhD program to learn ML actually at the beginning. So I was interested in music and audio at first. And then I, found this ML is really interesting. So I kind of learned more about machine learning during my PhD.
Interesting.
Yeah.
Cool. That's good. So very sort of maybe artistic, left brain thinking, I guess, or was that right brain, left brain? I don't know. Yeah, a little more of the creative side. But I mean, were you always into data and AI interfaces and stuff like that at all earlier on, or was it something you sort of picked up as you got into college and moved through it? Yeah,
actually, I really like to, always was interested in how to use some technology for some creativity. How to use those engineering skills or technology to boost our humans' creativity. So how to express a new way of making music or a new way of drawing some painting. So I've been always interested in those areas. And now there are a lot of people who is working on AI-driven art. That's also an interesting topic. I would say in daytime, I work on machine learning, and in the evening and weekend, I work on some art for machine learning.
Very cool. Well, I know when I checked out your website, you've got a lot of papers you've written, a lot of articles and stuff like that. And I think as we get into the interview, I want to touch on a little bit more with regards to maybe what's your favorite or what are some of the best presentations you think you've done. But I do have a question I kind of ask most people that are on the show here is how would you define AI? How would you define that to somebody who maybe is coming into this and doesn't really understand what artificial intelligence means?
Yeah, so AI is a really, really broad concept. To be honest, I don't like to use AI to describe my role because I feel like, if I say I'm doing AI, I feel like I'm solving all the problem in the world.
Yeah.
But if I define AI, I would say maybe it's kind of a system or computer algorithms that makes computers perceive our world and behave like human Or I can say some system makes computer do things that we think require human level intelligence. That's kind of AI that I see. But I prefer using actually machine learning
Okay.
to using AI when I describe my work. Because if I say machine learning, it's more like extracting patterns from the data. So it can describe more better what I've done actually.
Yeah, for sure. It's a little more focused, I guess, around the specific tasks where I guess in some ways artificial intelligence just seems so huge. Like you said, it could be solving anything. Perfect. Well, that's great. I'm always also curious, like, what is a day in the life of somebody who is, doing what you do? Are you in the code all the time? You know what I mean? Are you out in the field? Are you exploring? Are you trying different things? Obviously, we're in COVID now, so maybe you're, at home a lot. But like, if somebody gets into this field and they get a PhD and they go to 3M as an AI researcher or machine learning researcher, I guess, what can they expect to do?
So I think in terms of the work, I think you need to think about the kind of machine learning building pipeline. Let's say you have to first start to understand the problem or define the problem. If there exists a problem, then you need to understand the problem first. Or if there's no problem, you need to find or define a problem and persuade the stakeholder this is a problem to solve or something like that. And then you probably need to collect the data or inspect the data collected by your colleagues. So I think we're going to spend a lot of time on collecting data, inspecting the data, and understand the problem. And then maybe you can set up some research questions. So what kind of information you want to extract from the data, what kind of hypothesis you want to prove. Mm-hmm. And then finally, you're going to build a model and test it and debugging a model. So every single step is really important. So you're going to spend some time on every single step every day. Maybe you're going to have a different problem, but basically the pipeline is really similar. But a lot of myth is like, I see a lot of students who want to work on deep learning, machine learning area, but they're really excited about building model. But actually, you're going to spend a lot of time on understanding problem and inspecting the data, pre-processing the data. That's really important. Sometimes more important than building a model.
Sure. Fair enough. Yeah, I've heard that from a lot of people that have come on the show here to talk about that. A lot of it's data cleaning, and like
cleaning,
and you've got to make sure that you've got solid stuff. Are you defining problems, or it sounds like there's maybe a different group that's defining maybe some of the business use cases, and then they're bringing them to you? Or do you have a say in what you work on a whole lot?
Actually, as I said, I just joined my current company. So actually, I'm still learning. I think I'm still in the middle of orientation because 3M is really huge and there's a lot of things to learn. But if you think about my PhD work, usually every day you read new research paper and you brainstorm with your colleagues. And sometimes, a lot of time you need to define your problem or you find some problem from existing research. Yeah, so kind of both way.
Gotcha.
Sometimes you wake up and, I want to solve this problem. Or there is a problem that no one thinks is important. Then maybe you have to persuade people this is a problem. If I solve this problem, it's going to, maybe change the world or something.
Sure. Yeah. Sure. Yeah. Well, that's what gets you up in the morning, I guess, is, hey, I might actually solve a problem here that affects the world.
Yeah.
And it certainly can be done with technology and some of these new deep learning patterns and everything like that people are able to put into practice. As I talked about at the beginning with regards to your bio and your background, I mean, there was a lot of maybe complex terminology there, and maybe we could break it down a little bit. I mean, one of them was, I'm just kind of thinking back. We talked about you and audio signal processing, right? So sound event recognition, is that like maybe because some people come into this and they listen to this program and they don't maybe understand a lot of the details. Do you have an example? Would that be like, I don't know, I think of a glass breaking sensor maybe, at my house, I've got like somebody breaks a window. Is that something that you would be, working on? And did you write papers around that or take a look into that?
Yeah. So I've been working on a lot of sound event recognition, but here, the type of sound event that I was interested in is non-speech sound event, which is exactly what you described. Glass breaking or dog barking, car passing, that kind of sound. Yeah. So I always was interested in building some machine learning model or system that detects such a sound event as human does to understand the context of the world.
Gotcha. I know, like, I think the city of Minneapolis has like shot spotter, right? So gunshots or whatever.
Oh,
That might be something along those same lines. But how does that work? I mean, maybe break that down a little bit. Is it like literally you have to find all these other types of sounds of a dog barking, like millions of different dogs barking, I guess, and feed that into this algorithm, or are you able to let it sort of train itself for somebody that maybe doesn't understand how you would go about doing that? Could you explain that a little bit?
so depending on the kind of algorithm you're using, but let's say you are using one of the simple algorithms, which is supervised learning. That
Okay.
actually require the labeled event. So let's say I want to build a simple algorithm that detect my dog barking,
Okay.
barking of my dog. Then what you have to do is you're going to need a lot of different dog barking examples and other sound event that might happen in your environment. So non-dog barking, dog barking.
Mm-hmm.
Then let's say you have like 100 of dog barking, different dog barking, and 100 of non-dog barking. Then you let your machine learning model learn the mapping functions between the text dog and actual sound.
Sure.
So try to map between these two. So yeah, as you said, you're right that you have to collect a lot of different dog barking to detect dog because it try to extract some common pattern across all the different dog barking sound.
Sure. Sure. And you're actually looking at like the waveform, I guess, that's generated. Is that the level that you're looking at?
So usually you can actually start with those waveform, but a lot of research paper actually use image version of a waveform, which is spectrogram.
Okay.
So you can convert waveform into two-dimensional image. We can call it time and frequency representation. It's a different representation of an audio file.
Gotcha.
If you look at the spectrogram, you can actually see the pattern of the sound in image. So you train model on those image data.
Gotcha.
And it
Gotcha.
will become similar to image recognition, actually.
Yeah, yeah, for sure. Cool.
Yeah.
Yeah. I know when I go through and even when I edit some of these podcasts that I do
Mm-hmm.
in like GarageBand, for example, I get pretty good at seeing certain words that I know people say, in there that I want to either, remove, for example, if they're a filler word like an or an ah or a stutter, right? You can kind of see that. My eyes are getting really good. So that's kind of maybe that's what's going on is I'm starting to train in my head, but you could very easily probably train a model to do that as well, an AI system, right?
Yeah, so if you look at those time and frequency representations, for example, you want to edit your podcast, you have a podcast recording and you want to edit some like there is a sound alarm going on, but you want to remove those components. Then if you look at those spectrogram, actually there is some energy in high frequency because above the human speech frequency. Then you can simply delete those energies in the spectrum. There's some tool actually to do that.
Oh, wow. Cool.
Yeah.
I think about way back in the early days, there was this, and I'd have like an old stereo, and you could flip on the Dolby sound. Basically it was a noise reducer, right? And I think at the end of the day, that's kind of what it did. It basically sort of got rid of the high frequency hissing sound that you'd be hearing on your tape, your audio cassettes and stuff like that. And obviously, it didn't do it with machine learning. It did it with some sort of a transistor or whatever it did, but. Yeah. I could see a much smarter system these days being, hypersensitive and being able to, like you said, sort of extract those waveforms, sort of pull out the background noise, right? That's probably, that's kind of what's going on with some of these fancy headsets these days, right? These noise cancellation stuff. Would that be safe to say? With, I know like AirPods, like Apple's AirPods and stuff like that, they're able to just get rid of a lot of the background noise. So you can it hones in on somebody's voice or, what I've been really cool with around, I'm kind of going off a little bit of a tangent here, but like, it's really neat that like Alexa seems to be able to understand obviously my voice if I ask something. And at the same time, my kids are yelling or somebody else is saying, but like it seems to really be able to hone in on what I'm saying. Are those examples of things that maybe you've read about or that, these papers and stuff like that would sort of talk about?
Yeah. So you're talking about kind of speech diarizations. So different individuals have different tones and intonation and different patterns of sound, and we can call it timbre different timbre of a sound. So if you can train your model to learn those different timbre from different people, then actually, you can have a model then classify who talked this phrase or not in podcast phrase, for example.
Yeah, exactly. Yeah.
I think there are some commercial tools like for podcasters. So they automatically transcribe those human speech with different human speakers.
Yeah, yep, it does. In fact, I use a tool by a company called Otter, like Otter.ai, and I will run it through that tool. And yeah, it will hear the first person that spoke, and I tag it as me, and then it will hear you speak, and I'll tag it as you, and then it'll roll through the entire transcription. And you're right, it realizes the differences in our voice, and the transcription will get written out. It'll say Justin said this, and then I'll say Bongjun said this. So yeah, there are some pretty cool tools out there that can pull it out. I just find it interesting that obviously Alexa can seem to do it in real time, or in some ways. I mean, obviously, I guess it's not real time. Obviously, it's learned my voice over a series of me talking at it. But there's a lot of background noise going on in my house, but yet it can pick out my voice like from across the room. I can tell it to do something, and it can do it, right? And it just ignores all of the other noises going on in my house, which is pretty cool. Pretty cool.
Yeah. There's like a lot of interesting topic like active noise cancellations and beamforming. Yeah, all this stuff. So now Alexa, all the smart speakers have that kind of features. And now Alexa can also listen to non-speech sound like the glass breaking and fire alarm. So they actually released the service a couple of years ago, I think.
Right. Yeah. You're probably right. I mean, there's some really cool stuff you can do with audio inside your house that maybe, we hadn't really thought about in the years past, but now the speakers are becoming smarter and smarter along the way.
Yeah, I think the whole point of all this research, sound recognition research, is we have a lot of surveillance camera to understand the context visually, right? But there are also a lot of events that we need to detect only by sound. If you think of, like, for example, self-driving car. So when we drive, we also perceive some event by sound, not just looking at the event, right? So I think self-driving car also has to listen to audio, not just looking at the road through a camera.
For sure. Yeah, you talk about AI sort of mimicking what humans can do, and it needs, humans react based on vision, but also sound as well. So you're missing out on probably the entire picture if an AI system is only, seeing but not listening, or listening and not seeing, right? So
yeah.
Well, so one of the other terms that I use, I think at the beginning, that maybe some people may not be familiar with, is this idea of human in the loop. And maybe you could talk a little bit about what that means to somebody from the outside.
So human in the loop is a more like kind of interactive machine learning concept. If you think about machine learning model or AI model, we can think fully autonomous system, right? So you build a model, and then you let your model or your system run by itself to do something, right? But human in the loop is more like human and machine can interact with each other to solve problem together.
Okay.
So I applied that concept to one of my projects, which is called ISET, Interactive Sound Event Detector. So this tool is for ones who want to label a certain type of sound event in a long audio file. Let's say you have a long audio file and you want to collect all the time regions containing a certain type of sound event. And one way of doing that is you just listen to the audio, and just every time you hear the sound event you're interested, you just select those regions, the waveform, right? But it's really time consuming. And someone might say, okay, then we can train a machine learning model and we can let the machine learning model do all of those labeling for me. But problem is, let's say you have a long audio recording and you listen to it and you found an interesting sound event. You just found an interesting sound event.
Okay.
Then in order to train your model, you have to collect a lot more data to train your model. But you only have a single example.
Right.
So then how can we speed up this labeling process with the help of machine learning model? So in my tool, let's say human labeler found one single sound event in the long recording, and humans submit those initial labeled information to the system and the machine learning model. And the machine learning model searches through all the long recording and suggest me a couple of candidate reasons that I need to evaluate.
Okay.
So kind of like an interaction loop. Then human labeler listen to those suggestions suggested by machine and then label it and submit those label information back to the machine. So you iterate through this human in the loop. So
Gotcha.
working together, you're going to find a lot of sound events that are similar to what you just found initially. So that's what I call a human in the loop interface, because I built this interface.
For sure. You think there will always be human in the loop for interfaces, or is it some point in the future, and maybe it already exists today, but it feels like human in the loop is still used a lot, I guess, today to make sure that the model, even just like as a cross check or like a validation in some ways, but maybe not. I don't know. I'm just kind of curious, see what you think.
Of course, if we have a really advanced AI system, the best scenario is we just let machine do whatever we want, right? Without any human intervention. But since machine is not perfect, the idea is, okay, we probably need to give machine some human knowledge to boost the performance or to speed up the process, something like that. Yeah.
Yeah. So I guess at least in the near term, it's probably good to have a human at least in the loop at some. I guess what I was getting at was, do you feel right now that human in the loop interfaces are better than just letting AI just sort of just go crazy and do whatever it wants to do? Should there still be a check, at least in the year 2020 where we're at right now?
Yeah, I think it could be better in some application, I think, depending on how difficult it is. Like, it's better to detect more complicated pattern with really limited resources.
Sure.
Yeah.
And maybe limited data sets. I think about
limited data set.
I think about back to the dogs. Is there a public data set for dogs barking? I don't know if you were to, maybe that was fictitious when you thought of that, but it's like, how would you get that many dogs? And maybe you could get a smaller subset, but then through human in the loop, maybe, train it better.
Mm-hmm.
I don't know. I was just wondering if that would be the case, where if you have a small data set, you kind of need that human aspect to help train it. If that's true.
And also, one of the reason I built that model is actually the tool was for the one who have no knowledge of machine learning. So if you have a machine learning knowledge, maybe you can collect the data, build a machine learning model. But I wanted to give the simple interface to user that has no experience in machine learning, but somehow by communicating with this interface, they can train a model implicitly. Yeah,
for sure.
Yeah.
Have you heard of Mechanical Turk by Amazon?
Oh yeah, I've used it. Actually, I've collected some data set using Mechanical Turk before.
Yeah, and that's been around for a decade or more. I don't know. It's a long time, but it is kind of that idea where you feed it out to these people that are just sort of online, and you can let them they can have them help you classify what the information is, and you could easily maybe take that output and then feed it back into a model, for example.
Yeah.
So yeah, it's interesting. I mean, if there's a lot of people out there that can help you, at least if they're not, if they're available, you might be able to sort of mass produce or mass build this model. What I was thinking about too was, I was, like I said, I mentioned earlier, I was looking at your website and just like, there's a lot of, you've done a lot of presentations, you've done, obviously talks on so many different things. Even I think recently there was like a Midwest Audio Summit or something like that was going on, and you've got your name listed on just a bunch of research papers and stuff like that, which is very impressive. I was wondering, like, do you have a favorite, I guess, either be a paper or presentation you did over the past couple of years that you maybe wanted to, share a little bit with our listeners about, why that was special to you or what you had so much fun working on?
I have to say my favorite presentation is my final defense for my PhD. Actually, yeah, it includes all the projects that I've been worked on. But maybe I can pick another project, not other than the interface that I just talked about.
Uh-huh.
The purpose of using that interface is to quickly collect a sound event in a long audio file.
Okay.
The ultimate purpose is to collect the data.
Mm-hmm.
But what if your goal is to train machine learning model to use it for future purpose?
Okay.
But still, I want to reduce the human effort in labeling. So to build such a model, you have to collect all the data, right? So again, the same scenario, you have an audio file, you record it and you have to listen to it. And in order to build an accurate model, you have to label like this. For example, you have a 10 seconds of a chunk of audio, and let's say you want to dog barking classifier. Then you need to label like this. Oh, there's a dog barking between 3 seconds and 5 seconds within this audio file.
Right.
But imagine this scenario, it takes a really long time. You listen to it and, oh, there's dog barking starting, 3 seconds. Yeah. Okay, there's the endpoint, 5 seconds. So even labeling single event takes a really long time.
Right.
So my idea is, okay, then how can we reduce such a human effort in labeling to build a machine learning model? So I suggested this new way of training model on less accurate label data. The type of labeling that I just described is strong label because it has all the information, onset and offset of sound event.
Sure.
There's another concept called weak labeling. That means, okay, we have 10 seconds of audio. There's dog barking, but I don't care when actually it starts and ends. There is a dog barking somewhere in this 10 seconds.
Somewhere in here, okay.
Yeah, that's a weak labeling. As you can imagine, it takes much less time to collect such a data.
Sure.
As human labeler. So that's also known type of labeling. But the problem is if you build a model on just weakly labeled data, there's also a gap between a model trained on strong label and a model trained on weak label. So a lot of researchers have been working on improving such a weak model. But at the time, what I was thinking was, okay, instead of just spending more time on improving weak model, maybe I can suggest a new way of labeling that is stronger than current existing weak labels, but still takes much less time than collecting strong label. So I presented this one. I called it point labeling.
Okay.
So this is totally new type of labeling that I would say invented. So the point labeling is like this. So imagine that you are a human labeler. So you listen to the audio, again, 10 seconds of audio. And instead of saying start and end position of the event, you just specify single time position. Like, okay, 4 seconds.
Somewhere in the middle there, yeah.
Somewhere in the middle. So there's dog barking around 4 seconds. I don't care the start and end. But it is much stronger than weak labeling, because it has some amount of time information.
Sure.
But it takes much less time than collecting strong label. So that's the kind of like new way of labeling that I suggested.
Huh. Neat.
And then next part is, okay, then that's good. Then how can you train model on those weak label, those point labeling? That's another chapter of the paper.
Neat.
So yeah. So the result was really, really, really exciting. So the model trained on those point label was really, the performance of the model is really similar to the performance of the model trained on strong label.
Good. So you were able to get it close to what a strong label would be with much, much less, I guess, effort. Yeah. It would have been in the past. Excellent. That's cool. So that was a paper that you wrote, I guess, at some point a year ago?
2019, yeah.
Okay. Well, yeah, I have liner notes when I'll be broadcasting this podcast and, putting it out. So I'll have links to your website and links to all your papers and stuff like that. So thanks for sharing that. That's really fascinating. The other thing I was thinking about was, all this human focus, all this focus that we need to do on audio by humans today. And a lot of things I like to talk to people about that come on the program here is like, how does that going to change the future of work? When people have jobs that are into audio signal processing, for example, do you see people losing jobs because of this? Right? Do you see the change, of people getting out of work because of AI, or maybe it's not even sound, maybe it's just machine learning in general? What's your perspective on sort of how these algorithms are going to change the way we work in the future?
I think we're still early stage of this AI era, so there are still a lot of work to do to improve. And I think in near future, we will need more and more researchers and engineers to work on an AI model. And someone might think that there are so many research papers now coming out, and it seems like the performance of model is kind of saturated. But in reality is there's not that many AI system that is actually working and deployed and working in real industry. So, or services, or some like the user interface with machine learning is working. So that actually needs a lot of people who work on some like machine learning engineering part side of the things. So that's one thing. And also, I don't know when actually we can have really ultimate, I don't know, very good AI system. But what I want to say is, at least, I don't know, in 10, 20 years, we will need more people to work on this AI. And we're not going to lose that human job because of AI.
Okay.
Because as we build a more better AI model, I think that can create more job opportunities that we don't know yet.
Yeah, fair enough. Yeah. I mean, anytime there's advancement in, the Industrial Revolution or new technology that comes out, I think a lot of people get worried about, oh, is this going to basically make me and my job and my livelihood, obsolete? And it feels to me like we've always been able to overcome that. It's always been like, well, that's good. The machines are doing this, or, now these intelligent systems, it's not so much that we're building a machine. It's not like an engine anymore, right? It's not like you're getting rid of horses and replacing them with cars, because in that case, the horses just went away. Now, what's going on now is I think it feels a little more scary, because we're actually replacing knowledge. We're actually training machines to now actually have more knowledge, and that maybe feels like to some people that like, oh wow, this is something that's really going to impact me now, because it's actually more of a thought processing job rather than a mechanical action. You know what I mean?
Yeah.
That's going to take it over. But I talk to a lot of people when I interview people on this program, and I sometimes share the story. My dad was a doctor, a physician for his entire career, I guess, 50 years or whatever it was, but he did it for a long time. And you look at a lot of these AI systems now that can pick out cancer. And he was a cancer doctor, and so hematologist and oncologist, and so he's looking at blood, and he's looking at all these cancerous cells and stuff. And I tell him, oh look, there's a new AI here that's going to replace you for your job. And he always says to me is that's fine, but nobody has the human side of it. No one has that human touch, that one that can be empathetic and sympathetic with patients. And he never, he's not really worried that doctors are going to become obsolete because these machines can actually, predict it. So I feel like personally that there's probably going to be always this human side to it. This sensing. I think of the Myers-Briggs. I forget what the 4 letters are, but there is a sensing side of people that need to be need to deal with intuition and sensitivity. And I think, computers are going to have a hard time, or AI systems are going to have a hard time sort of, like replicating that.
Yeah. That's a really good point. First of all, the kind of system that we call AI now is actually really far from actual intelligence yet. And also, even if they have some intelligence, as you said, intelligence doesn't solve everything.
Yeah, for sure. Yeah. So still, the humans will still have a job, I think, at least in the near term. For sure.
Yeah.
Well, good. So, so as you're getting into this field, you've been like working on some really cool and interesting projects. Is there anybody that, that you look up to, I guess, that you're like saying, oh, geez, in this field, this person is completely just doing amazing work, or this is where I want to head in my career? What's sort of, you're still early on here and you've done so much, but, where do you think you want to be, or who do you want to emulate? Like, where do you want to go, you think, in the next 5-10 years?
So in terms of audio related, like AI field, I want to mention some of like interesting research group that I think is really doing a good job. Like, for example, there's an audio group at Google Research. There's audio understanding. They're doing really great job. Like, and also there are a bunch of university, not a bunch of, some university that doing some audio recognition stuff. But if you ask me about my like goal for the next 5 or 10 years, one of my problem is my interest is all over the place. So even if I've worked on a lot of audio stuff during my PhD, and I love doing that stuff, but probably, I don't know, maybe I can maybe start working on some new area. I don't know, but still I love working on data in general,
Sure.
Yeah, to extract some knowledge from data. It could be audio, it could be image, video. And also, I really love to work on some creative industry, even if it could not be a full-time job, but as a hobby or like serious hobbyist. Yeah. I want to keep working on those areas because actually before starting my PhD, I've worked on those areas for 2 years. But during my PhD, I actually didn't have that much time to do that. So, PhD life's pretty tough and busy. So, so now I'm planning to continue to do some of those we call it creative coding in my spare time. And I'll see how it will go. But yeah, probably I will keep working on AI, machine learning, and data and some other, I don't know, applications.
Sure. Cool. Well, you had mentioned sort of interactive media, interactive art, like music and stuff like that. And there's some really cool stuff you can do with sensors and really make things a lot more smart around the world. I've been kind of focusing a lot of my career over the past 10 years, or really around the Internet of Things. And whether you know it or not, there's a open source platform out there called Arduino, which allows you to do some pretty cool stuff if you're familiar with it. And that came out of actually an art school in Italy, actually. And so they wanted a simple way for people to create interactive art. And so they created this open source platform that allows you to pretty much plug sensors in, and you can code stuff with 10 lines of code. You can do some pretty amazing stuff. So really cool stuff. And you talk about data. Right. I mean, you can get all sorts of just awesome data, whether it be a gyro, score, doing stuff with your accelerometer, like you said, sound, video, all sorts of really cool stuff you can do and make it interactive with the world. So that's kind of a little passion of mine. It sounds like, you're interested in some of that interaction, some of the interactive stuff as well.
Yeah, I would say like my ultimate goal is not losing curiosity. That's my goal.
That is a great goal to have. Because I mean, the moment you're not curious anymore, you're kind of stagnant. You're standing still.
Right.
So and you mentioned Google. I don't know if you probably know about, and I'll post it too. But there's a pretty cool website called Teachable Machine.
Oh yeah, I know. Yeah.
Have you seen that one at all?
Yeah.
And so you can train it. You can basically record a bunch of different sounds of a dog barking, for example, or like all sorts of noise. Now it's very simplistic, but I think the thing that's kind of cool is it teaches people, like, okay, this is how it works. And while you have a small subset of data, at least people start to understand, it's not so scary. The whole machine learning, deep learning, system it's kind of approachable.
Mm-hmm.
People get worried and scared about all the math and all the stuff that's around it, but at the end of the day, it's like, I can kind of see how this works if I go to this website, this Teachable Machine website, and play around with some audio and some videos. So I don't know if there's any other sites or any other, I guess, even a more broader sense, like, are there books or advice on classes that you would suggest people, if they're interested in these subjects, to kind of, buy or learn, or conferences to attend?
For sound recognition related, there's 2 conferences that I've been attending. One is, we call it ICAS, International Conference on Acoustic Speech and Signal Processing. So you focus on a lot of acoustic speech and some also include vision because it's part of the signal processing. So that's a really, really big annual conference. And another one is workshop that focuses more on the sound event recognition detection. It's called DCASE. So detection and classification of acoustic scenes and events. We call DCASE. So the good thing about this workshop is they actually held DCASE challenge every year. So kind of like, you've heard of the ImageNet challenge, right? It's kind of like sound version of ImageNet challenge.
Oh, neat.
So you can go to website, and good thing about this website is since they're having this challenge every year, they also release some data set you can play around with, a lot of audio data there, and a clear evaluation metrics, so you can actually build your model and compare your result with other people's result. That's really good starting point for someone who are interested in the sound event recognition area.
Excellent. Very cool. Do you have any favorite books, I guess, AI or even non-AI related, right? So just outside of the field, that you've read recently, maybe that you found interesting?
I would recommend one machine learning book. So it's called Learning from Data. So it's by Professor Yasser.
Okay.
It's kind of like 6 years old, 7 years, I forgot how old it is. But actually, this is not deep learning book. It covers really basic of a machine learning model. The reason I recommend this book is, now people who recently started machine learning, they start with the deep learning, right? There are a lot of people who
Right.
didn't learn any basic of machine learning. They jump into the deep learning and like play around TensorFlow, PyTorch. But I think
Yep.
learning basic is really, really important. For example, it covers a lot of like what the training testing means in an ML experiment, what overfitting means, what is a hypothesis space means. So if you already started deep learning and if you want to understand more about basic machine learning, this is a really good book. And good thing about this book is it's really short. It's not like thick book. So it's really approachable. And also it actually have a companion website having a lot of the YouTube lecture. So yeah, this is really good. I think I highly recommend.
Nice. I'll definitely put that in the links. It's called Learning from Data.
Yeah.
Sounds awesome. Yeah. No, I in fact, I'm kind of, I've done that before with a lot of technologies. I think I've just jumped in and started working on problems, but without actually understanding the foundations of it. So this sounds like this would be good for anybody, just to kind of have a refresher, I guess, or maybe they never even got into the foundations of, like you talk about, what overfitting is, and test sets and validation sets, and kind of like why you don't want to, or why you want to exclude some of your data, into a certain set, so you can actually, validate it. So it's not everything gets trained on everything you have right now.
Yeah, I think the book will give you some practical and theoretical view of such a concept.
Excellent. Yeah. Cool. Well, very, very good. Well, we're kind of getting near the end a little bit here, but how do people reach out and connect with you? I know I'll put a link to your website, so that's really cool. You've got papers and stuff like that. Is that the best place to contact you? Are you on LinkedIn, or do you get on social media, Twitter, anything like that? Like how can people reach out?
So yeah, you can send message on LinkedIn, or maybe the best way of doing is, I think, to email me. So I have an email address on my website.
Gotcha. Excellent. Cool. Good. Well, I guess, was there any other thing that I didn't touch on, or I guess that you wanted to bring up around, audio, non-audio, other projects that you're working on, maybe things that people should think about as they get into this field? We think we've covered it pretty well.
Actually, there's one thing I've learned hard during my PhD about machine learning. So I saw a lot of people who work in machine learning project, they don't look at the data. That is really important, but a lot of people ignore such important concept. So for example, you have trained some different models and compared the performance different models you built, and you only look at the final accuracy. So let's say you build a model and you got some 95 accuracy, and you build second model, get a 99 accuracy, and you say, okay, second is the best. You pick the model, but actually, someone never look at the data, what the first model misclassified, the second model is misclassified. So if you are working on audio, please listen to audio. If you working on image, please look at the data. I would say at least you have to spend one day before building your model, inspecting your data. That is really important. But I see a lot of people who miss those really important steps. Yeah, I've learned this from my all of PhD project.
That's great advice.
Yeah.
That's great advice for sure. Awesome. Yeah, I write a lot of software. I have written a lot of software in my career, and we have this idea of doing this test-driven development, right? So you write these tests, and then you basically, once the test passed, and your code's working, right? Or at least it's supposed to be following the thing is. But the problem is you can write flawed tests. And so the tests are passing everything, you get this green bar if you're testing stuff with this, thing called JUnit. So you say, oh, I want to make sure the bar is green. So you get the green bar and you've got 100 tests that are passing. But to your point, are you testing the right thing?
Yeah.
Right. And so it gives you a completely false sense of security unless you actually go in and essentially validate. Is the code doing what it's supposed to be doing? Because it's a black box, and I send in a value and I get the right value back. But was that even the right value I was supposed to send in? So very, very wise to, like you said, make sure you actually visually inspecting it, or in a lot of ways, just making sure your assumptions are valid.
Yeah, exactly.
A lot of these cases. So, well, great suggestion for sure. Well, great, Bongjun. I definitely appreciate you being on the show, taking the time to talk with us, sharing all of your knowledge and your experience with all of our listeners. Looking forward to having you at our next meetup.
Yeah, it was fun. Thank you.
When we air this will be after the meetup, but we're going to be talking through, I think, a lot of these really cool things, and we'll be recording that as well, and being able to share that with the community. So again, I appreciate the time and sharing all this information, and look forward to keeping in touch.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at appliedai.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at appliedai.mn if you are interested in participating in a future episode. Thank you for listening.